In this video today, we are going to talk about the basic differentiation rules, including the ones that you did your explorations for. We will be learning the constant rule, the power rule, and the constant multiple rule, and we will be applying those rules for derivatives in some examples. So first we're going to start with the constant rule. So the questions I have are, what does the graph of a constant function look like? If you think of the graph of a constant function, that would be y equals some number. That's a horizontal line. Horizontal lines have a slope of 0, and since derivatives are the slope of the tangent line, the derivative of a constant function would be 0. Another way to think of that is using this graph here. The slope of a horizontal line is 0 because, and so the derivative is also going to be 0. It does not matter what way that you show that equation. If you have y equals 7, that's a constant function. The derivative of that is 0. If it's written as f of x is equal to a constant 0, derivative of that is 0. Even negative numbers, derivative of that is 0. And as long as k is considered a constant and not a variable, this is all a constant, and the derivative of that is also going to be 0. You did your exploration for the power rule. In your exploration, you figured out that if you have a function that has a power, x to a power, you would take that power, make that the coefficient of your derivative, and then subtract 1 from that power. That's what we call the power rule. So some examples of using the power rule. If I have x to the third, I'm going to take this power here, move it, and make it the coefficient, and then subtract 1 from that power to get the new power. That would be the derivative of x to the third. For this one, we want to change that to a fraction so that it's actually a power instead of a root. Then we can use the power rule the same way. Make the 1/3 into the coefficient. 1/3 minus 1 is the same thing as 1/3 minus 3/3. So we get a negative 2/3. Here we want to change this so that it's a negative power, so that again we have a power. So the derivative is going to be that power as the coefficient, and subtract 1 to get negative 3. Next, we're going to look at the constant multiple rule. We want to remember what the constant multiple property of limits was. When we got the limit of a function, and we also wanted to know what the limit of that function times the constant was, we could just take the limit of the function and multiply it by the constant. The same rule applies to derivatives because derivatives are limits. So we can just take the derivative of a function, like x to the third, and then if there's a constant in front of that, like 2x to the third, we just multiply 2 times the derivative of x to the third. So some examples on how to do that. Here we have the constant 5 in front of x to the third. So we ignore that 5, use the power rule to get our 3x squared, and then we can multiply the 5 times 3. Now, you don't have to work all these steps out every time. You can do that part in your head. Just multiply that 3 times that 5 there and go straight to this piece here. In the next one, we're going to change this to 2 times x to the negative 1 power. So then our derivative would be negative 2x to the negative 2 power. This one we want to look at as 4/5 t squared. So then we can multiply the 2 by the 4/5 to get 8/5 t. Since this is a root, we want to make it a fraction power again. Multiply the 1/2 by the 2 to get just 1x. Subtract 1/2 minus 1 to get negative 1/2. This one, we're going to change to 1/2 x to the negative 2/3 power. So then we'll multiply negative 2/3 times negative 1/2, or times positive 1/2, which gives us negative 2/6 or negative 1/3. When we subtract 3/3 from negative 2/3, we get negative 5/3. This one we want to write as negative 3/2 x. And so that is just going to be our negative 3/2 since the derivative of x is 1. The sum and difference rules, again, we're going to talk about what was the property for limits. The property for limits was that when you had a sum and difference, you could take those sum and differences of different limits and just take those limits and add or subtract them. And the same works for the derivative. I can take the derivative of f of x, the derivative of g of x, and I can add those derivatives to get my final derivative. Or if it's a subtraction, I can do that. This works for polynomials a lot. So you'll notice that that will be used. We've been doing the power rule for monomials only. Now we can use the sum and difference rule in order to figure out the derivatives of polynomials. So here, these polynomials, the derivative of x to the third is 3x squared. The derivative of negative 4x is negative 4. The derivative of 5 is 0, so this is my derivative. For g, we have negative 1/2 x to the fourth. Negative 1/2 times 4 is negative 2 x to the third. Then we can multiply the 3 times the 3 here to get 27x squared, and then minus 2 for the derivative of this piece. This one we can change to look like this, because I can just divide each of these. This is x to the negative 1, so we can use the power rule and the constant rule on these. The derivative of this one is just 3. The derivative of that constant is 0. And the derivative of x to the negative 1 is negative 1 times x, and then x to the negative 2.